Okay, so in last lecture we have studied basic definitions of voltage, basic definition of current, what is resistor, and we have studied the, the let's begin from here. So we have in last lecture studied of current. Voltage. Then we have studied this resistance. What is resistance? Is basically a property of material to resist the flow of electron, known as resistance. Then we have studied the Ohm's law, at how Ohm's law works. V is equal to I, basically V. And we have studied two limitations of Ohm's law. First one being that is not applicable to unilateral network, the networks which have a single direction current flow, and the other one being a non-linear element present in the circuit. There is a non-linear element, won't follow the. So now we'll go ahead to the next topic, and that is related to resistance itself, and that is, and this two graph we have seen. This is the graph of that. This is non-linear in nature, and this two are linear in nature. So the slope is of the graph is different. Basically, the slope of the graph is the your resistance value. So if you find out the slope of this curve, you will find out a large slope, and this will be very small. So that is a large resistance or small resistance. Now we'll begin with resistors. Okay. Any doubts up to last lecture? You may have. Any doubts up to last lecture?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
No doubt, sir.
Okay.
No, sir.
So now we'll begin with the resistor. You can mute yourself. Because I'll be muting everyone. Okay. So now we'll start with resistors. You must have seen resistors. Something like this. It looks like this. You must have seen this element. This is known as resistor. These are basically a resistor which we use in the circuit formation or some small application, or you may have seen it in some ready-made PCBs. So these are basically we know this resistor since last 3-4 years in the green PC. Resist the flow of current, and that is most of the cases is a mixture of clay and carbon. So inside there is a carbon. So there is nothing like inside it. It is actually made up of carbon and some clay material, combining the two in some proportion, but providing the different resistance value. Basically, these are the resistors, and it is used to limit the current. Okay. Do you know any small application of this resistor? Like you have seen that small application of this resistor you have come across in your life.
Regulators of fan.
Regulators of fan. Okay, then other than that,
Electrical heaters.
electrical heaters, correct? Then
Light bulbs.
light bulb, correct? Have you used this kind of resistor anywhere? Like in your life, you have used in some application?
Electrical circuits.
Electrical circuit, but when you give an example of a circuit,
Fuse.
why you use
Calculated.
that one?
Motherboard.
Sorry?
Motherboard.
Motherboard. Okay, but we are not using it. We are not using it in motherboard directly. Company does provide us. Okay, a very basic application. I'll show you. You must have seen this. potentiometer.
Arduino.
A very basic example I'll give you. You must have seen an LED. LED જોઈ છે બધાએ?
Yes, sir.
Basically, it is kind of this
Yes, sir.
Yes,
diode.
sir.
Now there is a one issue with this LEDs. LEDs come in like various sizes depending on how much light do you require. So we do use a general LED, or that red one or green one. Which one is that? Here I search LED. You see this kind of LED I'm talking about right now. A very basic LED. So a general issue with this LEDs are this is current sensitive device. This LEDs are current sensitive device, and whenever the current flows from this device, if this current goes beyond some milliampere range, like generally it supports 10 milliampere, like 10 to 20 milliampere it supports. But if your current goes beyond this value, like if I try to apply 50 milliampere from this, immediately this device will blow up. Like LED literally blows up because smoke bhi nikle. So to limit this current, we use resistor, and we calculate the value of this resistor depending on the value of resistor provided here. See, this is the circuit. This is very basic circuit. I have one battery. Let us say this is a 12-volt battery, and this is 0.3 watt or 1 watt LED. We know the wattage rating. Depending on that, we can find out the current rating. What would be the current required? And don't go in this way, like it is not always 12 volt, like it depends on my design. Right now, if you find out from these two values, you won't getting 10 million. I'm just giving an example. So here you have to provide a resistor. Why? To make sure there is no current beyond this limit. Like you have to always check that current remains in this limit. Less than 10 milliampere, always good. But if it goes beyond 10 milliampere, your LED will blow up. Like if you are supplying 12 milliamp, it won't blow up immediately. If I supply 12 milliampere, it won't blow immediately, but it will blow up eventually at some point of time. It will heat up, and it will blow up, or it will just die. So here we require this resistor, and you have to select this resistor depending on the LED. If I have two LED, I have to change the value of this resistor. I have three more in the parallel, I have to change the value of resistor. So this is very basic example of application of resistor to limit the current flowing through LED. Depending on the current, LED will change its intensity. Like your LED bright કર્યો તો અહીંયા resistor ની value ઓછી લેવાની. And if you want your LED to be dimmer, go low light જોઈતો, in that case you will be having a value or high resistance. Or what you can do is you can just connect a potentiometer like this. So if I vary this, my resistance will either direction, either go up or it will go up. So this is a basic example of a resistor and how you can use that resistor in real life. So these are the resistors. Now the issue is that I know I want to use a 1 kilo ohm resistor. I want a 1 kilo ohm resistor, but these resistors are always comes in like this shape and with this color band. So you have to identify which one of this is 1 kilo ohm, and it is a big challenge. Okay, so to identify this kind of thing, like which resistors, how many provide how many ohms of resistance, it has been colored to identify. So you can see this kind of bands on the resistors. You can see here as well. Okay. There are red, blue, orange, yellow, golden, silver. Lot of colors variety are there, and each color and the position of each color means something to us. And by this color of bands, you can find out what value of resistance is this one. Okay. For an example, resistor is having a first red band, the second one being a violet, third one being yellow, fourth being black. So this first four that are very near to each other, that four band decide the value of the resistor. So your first band, by looking at the color of the first band, here it is red. So you will see there is a red. So red implies value of 2. So this right band contains value 2. I am writing 2 here. Then my second digit depends on the second band. So I'll look at this. This is violet. I'll give 7 to that. Then next is yellow, so I'll give a 4. And then the fourth one is your multiplier. Like 10 to the power you have to put depending on this color. Right now, it is multiplier of 1 ohm. You can see this is a multiplier as 1 rather than 1 ohm. You can read it like 1. Multiplier of 10, 100, 1k, 10k, 10, 100k. So right now it is black, so it is being 1 ohm. Okay, or you can say multiply by 1. So I can write 2, 7, 4 into 10 to power 0. Why? Because I have to multiply it by 1. Here it is 10, so 10 to power 0 is always 1. If I want to multiply it with 10, I will write 10 to power 1. If it is 100, I will write 10 to 2, but right now it is 1, so I will write 10 to 0. And the overall value is 274. 274 into 10 resistance. This resistance is 274 ohm. Now, other than this 4 band, there may be additional 1 or 2 band. Additionally, other than this 4, there can be 1 or 2 additional bands. So here, the fifth band decide the tolerance value. Tolerance value being mostly you will see this band to be either golden or silver. You will rarely see a red, brown, and most rarely see this violet, because this is too precise resistance. Like if I say 1 ohm, it would be 99 ohm or 101 ohm if I say tolerance is in violet band. But if my tolerance is golden and silver band, I can say this being 274 ohm. Right now it is red, so plus or minus 2%. So 274, 2% is like somewhat like 27 into 2, around 50 ohm, let us say. So it can be of 274 minus 50 or 274 plus 50. Sorry, it would be 20, 2.7. Oh, it would be 270 or 280 maximum in that range. 274 to plus or minus 2%, depending on the color of this band. Okay, that is a tolerance band. So what would be the value of tolerance? Like if I say something is of this value, but when I construct that thing, there are possibility some error in it. Depending on that error, we provide this. The more precise resistor is available, the more costlier it would be. These are the general purpose resistor, plus or minus 5% and plus or minus 10% is general purpose resistor. Whenever you design some application, you'll always bought this, either with these two. Market now mostly these two are available. But if you want to use this one of this, you have to pay extra cost for this. Okay. These are the precision resistors. So this band declares the tolerance value, and the last one, we will never use this. You will never use this. But just for your information, it is a temperature coefficient. This band defines the temperature of coefficient of the resistor. So basically, that depends on the material used inside. From that, it has given. And if it is 250 ppm per K, that means parts per million per Kelvin. If the temperature changes by 1 Kelvin, 250 parts per million value will be changed by resistance. So you have to multiply this with 250 into 10 to power minus 6 per Kelvin. We are not going into that. That is not useful for us, but this is just for information. You might see somewhere this, but we are not going to have example on this. But we will have example on this first 5 band or 4 band. So in market, you may see a 4 band, a 5 band, or a 6 band resistor. If it is a 4 band resistor, you will see a 3 band that declares these digits, and the last one being the tolerance. Okay. If it is a 4 band resistor, you will get 2 digit, first, second digit, and this would be a multiplier. If it is a 4 band, you will get something like this: first digit, second digit, third digit, and then multiplier. But the last one is always a multiplier. Remember that. If it is a 4 band, like in this case, it's not like this is first, second, and third digit and no multiplier. This one is actually multiplier, and you are only having a 2-digit information. So for this 4-band example, let us say what is the value of this resistor. First being brown, you can say it is 1, right? 1. Second being red, I'll say that is 2, 2. Third being green. But this is not my third band actually, so I don't read this value. Rather, I'll read this value. It is 100k. 100k is nothing but 10 into power 5. So 10 to power 5. I'll write 1 2 into 10 to power 5. This is golden color, so it is tolerance value of 5%. So I'll say this resistance value is 1.2 mega ohm, or I can say 1200 kilo ohm value. Same example is given. One more example given here. One more example is given here for 5-band. Here you will see first brown, so I'll write 1. Second and third is being 0 0 because it is black 0. And last one is here. There are 3 for the information of digits and 1 band for multiplier. Multiplier is always there. So here the multiplier is red. That means it is 100. It is 10 to power 2. I'll write 10 to 2 plus or minus 1% from this information. It is brown. And that overall value would be 100 into 10 to power 2. Is 10,000. Or you can say 10 kilo ohm resistance is there. Okay, clear how to read this? Now you might be knowing how to remember this. If you remember this,
Yes.
if you remember
Yes,
this,
sir.
and then you can write down.
Yes, sir.
Okay,
Yes, sir.
can someone let me ask someone? Roll number 11, Anand. Anand, please turn on your mic. Yes, Anand, can you tell me how to remember this? There is a trick, if you know. I'm not sure everyone might be knowing.
Leroy of Beat Beaten having very good wife.
Yeah, there are different ways. This one was a new one. Basically, when I was studying in 12th or 10th, I used to remember it like BB Roy.
Of Great
Yeah,
Britain.
yeah, something like that. So you might be remembering that, and you can share it among your group. I'm not sharing that thing, but there is this thing that to remember this, because if you don't remember the color in sequence, you won't be getting this information, and it would be very difficult to uh, calculate the value. There would be an example in this in exam. There would be an example based on this, so you have to remember this. This sheet won't be provided to you during the exam. Okay, so this is how to read a color code of a resistor. Now, uh, any doubts in this? Like anyone having a difficulty in reading this resistor? Let us have an example of one more resistor. Google resistor. Okay, let's say an example of colors. How do they call? Yeah, this one. This one. Okay, example of this. This is 4-band or 5-band? 4-band.
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 4-band. Okay.
Four band.
So first two are for
Yes,
digit.
sir.
The third one is for the tolerance. Sorry, multiplier, and the last one is being tolerance. Tolerance is golden color. Okay, we know that. And the
Seven.
other three. The first one being green. Let us see what is the value of green.
7.
7.
7.
5.
7.
7.
Five.
5. It is 5, not 7.
5.
Okay, so first is 5. The second one is blue. That would be a 6. And
6.
the third one is orange. The third one being
10
3.
is to 3.
Correct.
Multiplier.
અહીંયાથી 3 લેવાનો કે અહીંયાથી 1k લેવાનો?
Multiplier.
Multiplier લેવાનો બરાબર. So I'll go with 1k. So it is first being green, second being blue, and third being 1K. So it is 5, 6 into 10 to power 3.
3.
So it is basically 5600 or 5.6K resistors. Okay. So in this way, you can read this value of different resistors. So I hope you all are clear on this, how to read this. So I'll share this sheet with you, and you have to memorize this thing. Then and then you will be able to perform the exam. But you have to perform some example in the exam. Okay. Kindly. Om, kindly turn off your mic. Now we'll move ahead and we'll see a very common equation that you have already studied at some point of 12th or 11th. That is this equation: R is equal to rho L by A. This equation is basically used to find out the value of resistance from the physical properties of the material. What do I mean by physical property is these three. First is being material itself, whether it is a copper, whether it is a silver, whether it is a nickel or some other metal. This one being the size of the my object. Like if I say I have an iron rod of 1 meter long and zero point 0.5 square diameter, then from that information I can easily find out what would be the resistance or what would be the resistance offered by that rod. So that three things can easily use to find out what is the value offered by the material R. Okay. What are the three things? First is resistivity. How I know that resistivity? So to find out what is the resistivity of any metal, I must know which metal I'm using. For example, copper, the value would be different. Silver, the value would be different. I'll show you. You will see something like this somewhere. So see, for the copper, the resistivity is 1.68 into 10 to power 8. Will be changing to 2.65 into 10 to minus 8. Tungsten is 5.6 into 10 to minus 8. We don't have to memorize this value. I'm just giving you example how this value differ from material to material. So basically this value, I'm reading this value is this row. So if I say my rod is made of copper, knowing that the value of rho would be 1.68 into 10 to minus 8. If I say that is from aluminum, we'll know the value of rho is 2.65 into 10 to minus. So this parameter is the resistivity, and that depends on the material itself, which material I'm using. The other two, L and A, are the physical property of the object. For example, if I say rod, so I will be having a length of the rod and I will be having the cross section area of the. So these two parameters are come from that, that information, length and the cross section area. So if you have this three information, you can easily find out the resistance offered by the object. Okay. Now, when we were studying this, I have asked you which are the various why we write this in the Ohm's law. Physical condition of the conductor do not change. The physical condition means this three things. Material itself, okay, material must not change, its length must not change, and its area must not change. Otherwise, what will happen if either of these three changes? Immediately your resistance will change and your Ohm's law will fail at that point. Why? Because you are changing the resistance itself. So V into I, V proportional to I, it depends on this R. R is constant, we say. But if you change R itself, that constant value is changing, and constant can change. We know that. So object being the same, Ohm's law will always follow if the object is same and physical aspects of the object does not change. So this is the basic equation. The resistance of a conducting material is found to be directly proportional to length, R proportional to L, and inversely proportional to cross section area. So if I write R proportional to L, I can also write R proportional to 1 by A. And the nature of material, whether it is aluminum, whether it is copper, depending on that, I can include this and depend on the temperature. So what is the resistivity? If someone asks you what is the resistivity, it is basically characteristic of a material. There is resistivity or opposite to resistivity, there is a conductivity. Resistivity is to oppose something, and conductivity is to have something to conduct. Like the resistivity is to resist, and conductivity is to conduct. These are two opposite things. From resistivity, you find conductivity, and conductivity can get you resistivity. They are mirror of each other. But if you want to find out resistivity from conductivity, you have to find out resistivity is equal to 1 upon conductivity. And if you want to find out conductivity from resistivity, you will say conductivity is equal to 1 upon resistivity. So that two are mirror image of each other. Inversely, like is an inverse relation in that. So is a fundamental property of a material that quantifies. This is basically to quantify something, how strongly it resists or conduct the electrical current. This is the basic definition of resistivity. And resistivity is commonly represented by the Greek letter rho, and the unit is ohm into meter. So to find out this resistance in ohm, this quantity is ohm meter, length is generally in meter, and this cross section area would be in meter square. So that 2 meter will cancel this meter, and the value of resistance is in ohm. Okay, the SI unit of resistance is ohm. So whenever you calculate some example based on this, make sure you keep in mind that this is an ohm meter. So you take that as an ohm meter and in meter, and take the cross section in meter square. Otherwise, you will fail at the value. Like digits would be correct, but the decimal point would be incorrect. Okay. Someone will get 10 ohm, someone will get 0.10 ohm, someone will get 1000, just due to this error. So make sure whenever you calculate example of resistance, the length and area is in meter and meter square quantity. So convert it in them if it's not directly available. Okay. Now we'll see example based on this, and then we'll complete this lecture. There are 4 examples. From that first one you have to calculate. Second one will calculate side by side. Third one will calculate, and fourth one is homework. Okay. So first example based on this is something. First we'll see the example. You must have a note, a pen, and a calculator along with you. Then and then you can calculate. So if you do not have, I'll give you 1 minute. Quickly bring it. You'll need a basic calculator, like a mobile calculator will work. You don't need sine, cos, tan, nothing. You just need a simple calculator. Bring a calculator, pen. Okay, if you have any doubts, you can raise the doubts. Meanwhile. If you have any doubts, you can raise the doubts meanwhile while we wait for others. Okay, I hope everyone is ready with calculator and a pen and a paper. Now clearly uh, make sure you follow my instruction. First instruction is that everyone has to calculate the example. Second one is no one will answer until I ask, and I will. The only person who is answering is I'll call out either by a name or a roll number. Then and then answer, otherwise won't answer. Okay. I'll ask to directly to some student for the answer. So everyone has to calculate. If you are not calculating and if I ask you, you might be in trouble. Okay, I'll show you the question now. Coil consists of 2000 tons of copper wire having a cross section area of 0.8 millimeter square. This is not meter square, this is millimeter square. The mean length per ton is 80 centimeter. This one is in centimeter. And resistivity of copper is 0.02 microohmeter. Calculate the resistance of this coil. I'll give you 2 to 3 minutes to calculate and then I'll ask someone. Keeping the screen on, read questions number of times, then start to. I'll provide a roughly 5 minutes. You'll require more time. Just a moment, I'll switch the screen for a brief. Back to it. Okay, is it visible?
Yes, sir.
Yes, sir.
Calculate now. You can raise hand if you have completed.
Done, sir.
Just raise your hand from your screen. Roll number 24, Teeth. Roll number 24, Teeth.
Yes, sir. My answer is 40 ohm.
40 ohm, okay. Viral, roll number 35. Viral, roll number 35. Can you answer the question? Viral,
Sir, back check it.
he completed. Roll number 18, Raj. Yes, Raj, what is the answer? Raj, 31, roll number 31. Aisha,
The answer is 40 ohm.
40 ohm. Okay, so I hope everyone is getting the answer 40 ohm. How you perform this? So it is very simple. First, you have a 2000 ton copper wire having the cross section area of 0.8 m and the mean length per ton. So per ton length is 80 centimeter and we have such 2000 tons wire. So we'll multiply this 2000 tons per ton is 80 centimeters. So I'll multiply 80 with 2000. Whatever is the answer. So answer would be, let's calculate. It is, sorry, 80 into 1000. It would be 1,60,000, but this would be in centimeter. So I will convert it to meter. So it would be roughly 1600 meter of wire. Okay. The cross section area is 0.8 mm square. So to convert to millimeter to meter, we require 10 to minus 3. But this is millimeter square, so I'll have 10 to minus 6. So what I'll do is 0.02 micro ohm. Micro ohm is 0.02 into 10 to minus 6 into 1.6. Let me write it for you if you have trouble in that. Okay. So here, what we have is actually 2000 ton wire. Okay. Each ton have 80 centimeter. I'll multiply this 2 and I'm getting 16000 centimeter. I convert it to 1600 meter. Other than that, I have the diameter of the diameter is 0.8 millimeter square. So this is my L. This is my L. Now I am talking about my area, cross section area A. So A is equal to 0.8 millimeters. So I have to convert this millimeter square into meter square. To convert a millimeter into meter, what I do is power 10 to minus 3. But here we have millimeter square, so I'll square it. Actually 10 to minus 6. My area A would be 0.8 into 10 to minus 6. And micro ohm meter. So value of R would be rho L by A is nothing but 0.2 into 10 to minus 6. This is 0.10 to minus micro ohm. So this is ohm meter now. Multiply with 600 divided by 0.8 into 10 to minus. This two will cancel out each other. This would be 4 and this would be 400 आंसर है हमारा क्या भूल गई it is 0.02 and not 0.2 but this value is wrong that's why This is 0.02. This is 0.02. So again 10 to minus 1, so it would be 4. Mine says 40. This is how you can calculate this example. Okay, the next example is little bit tricky. Answer is 40 ohm. The next example is this one. You have to calculate it first, or I'll calculate first. What do you suggest? Let's read it out first. A wire has a resistance of 2 ohm. It has been stretched to the length of 3 times that of the original. So suppose original is 1 meter, I am stretching it to become like until it's 3 meter. Now whenever I stretch the wire, what will happen? The area will shrink out. Like diameter say that will reduce because I'm stretching it. Like આપણે rubber band ને stretch કરે તો કેવું rubber band ખેંચાઈને વચ્ચેથી પાતળું થઈ જાય. Cross section area will reduce whenever I stretch something. So now if I stretch it 3 times, what would be the new resistance? આપણે calculate કરશે. The only information we have is the 2 ohm and I am stretching it to 3 times of the original length. So from this two information, you have to find out what would be the new resistance of the wire. Okay, can you do it?
Yes, sir.
Okay, so quickly complete this. Kindly turn off your mic meanwhile, like mute yourselves. Yes, anyone who has the answer?
Yes, I got.
Yes, sir. I got it.
Yes, sir.
Yeah,
Yes,
please
sir.
tell me the answer. Anyone?
Yes, sir.
18
Sir,
ohm.
18.
18.
18.
How to do this? If someone has difficulty, we'll try to solve this. We know that R is equal to rho L by A. Here we know the value of R. Let me check it. This 2 ohms. I know the value of R, that is 2 ohm. And I know the length is the length was L, and from this I have converted it to 3 times. My length has been increased 3 times. Now, before calculating this, I must know one basic principle. Whenever I stretch something, like for example, if there is a rod like this, okay, the length was L, I'm stretching it and I'm making it like long. What will happen whenever I stretch it? Length will definitely increases. Let us say this is 3L. Definitely the length will increase this area. Whenever we do have a rubber band and we pull it apart, the same thing happens. Like, initially, the rubber band looks thick, but when we stretch it, it becomes thinner. So same thing happens here. But the main point here is the volume. The volume of the matter remains the same. Like whether be it L length or 3L, if I'm stretching this thing from this object to this object, the volume or the material inside would be same. So if the volume of this thing was L into A, the value of this thing would be 3L into, let us say, small a. What is this small a? Small a is the shrink cross section area that I don't know. But do we require this? So I can say, no, I don't require this. Why? Because here the volume is constant, and if I know the volume of this thing and volume of this thing, I can easily find out what is this. But here we do not know volume as if now. But we'll try to avoid this volume at all and this area at all. What I can do is, this is the basic equation, L is equal to rho L by A. Okay. Now I'll try to introduce volume in here. So what would be the R of new material? This is R1, that of old material. So let us say this is L1 and A1. Resistivity won't change, so rho will be as it is, but L1 will change, and L1 will become here L. The length of new object is okay, 3 into L1. What is the A? So I don't know A. Basically, I know this. L is equal to actually 3 times the original length. Original length was L1. So my new length is 3 into L1. This is the original length, 3 into L1. I don't know A. Nothing to worry. Let us say area, let us say volume is equal to area into length. Okay, volume can be find that. Okay, I know the length, I know the cross section area. So if I multiply that to, I'll know the volume of this thing. So V is equal to A into L. Okay. So here, let us say the initial A1, I'm replacing this with this equation. What I'll do is, this is A1 and this volume is as it is, and this is L. V is equal to A1 into L1. So I can replace this and I can write it like this. V is equal to L1 divided by A1. So V into L. And same way here I can write it like this. 3L1 divided by, this would be A2 now. So A2 V is equal to A2 into L. But V remains same. What I can write is A2, this is A2, is equal to V by L2 by L. But L2 is nothing but DL1. Actually, this is 9 V. Same way, this is R2. Same way, R1 is here. Rho L1 into L1 is nothing but L1 square divided by. Now, if I take the ratio of R1 to R2, I can say rho L1 square divided by V, multiply it with by V, and give 9 rho L1 square plus rho V. Only things left here is R1 divided by R2 is equal to 1 upon 9. Now R2 we know, R2 we have to find out, so R2 is equal to 9 into R1, and R1 is 2. This is how you calculate this example. This is the longer way, there is a shorter way. Just multiply it with L, one more L, and AL will be there. Just replace this by volume. Prove that this R is, there is the shorter way. We can go with this way. This is the longer way, but here we can get a better explanation to the problem. Okay. So this was the solution. 18 ohm was the answer. Okay, there is one more example, but we'll do this in the next class. and I'll give you a homework of one example. The same example, just we have calculated, but here I have changed two things. Just write it down, and then we'll end this session. The value of the resistance is 3 ohm, and it has been stretched in such a way that the diameter of the wire is half. The diameter જે હતો previously એનાથી અડધો થઈ ગયો ત્યાં સુધી મેં એને ખેંચ્યું છે. So you have to find out what is the new resistance of the wire. This is for homework. Whenever we'll have a next lecture, probably after this Diwali we will be having lecture. I'll start with this example. Write down this example and you can leave if you do not have any doubt. If you have doubt, you can be here. Okay. I'll post this in comment section as well, so you can directly have it. I'm posting this question on comment section. Now, anyone have any doubts? Anyone has any doubt? Yes, Karan, do you have any doubt? Karan, Sanket and Uvesh, you are raising your hands. Sanket, do you have any doubt? Okay, you can leave now. We'll close the session here.